All right, so here we have 3.6b, which is our favorite word problems. Woo! So systems with 3 variable word problems. And so our objective today is to write, oh, that was a little bit gross, sorry y'all. Write and solve systems of equation word problems with 3 variables using elimination and substitution. So this truly is just a continuation of yesterday, really. Like the solving is no different. It's just the fact that we now have to set things up. So I'm going to basically write out the whole word problem that we're going to deal with. We're going to write the equations and go from there. All right, so here we have a stadium has 49,000 seats. Seats sell for $25 in section A, $20 in section B, and $15 in section C. The number of seats in section A equals the total number of seats in sections B and C. So suppose the stadium takes in $1,052,000 from each sold out event. How many seats does each section have? And so first what we would need to do is we need to label our variables. So I would say that A is section A seats, B is section B seats, and C is section C seats. Okay. You can label however you want, but basically we have sections A, B, and C. So the first thing is we're told that the stadium has 49,000 seats. And we're talking also about a sold out event. That means the seats in section A plus section B plus section C would have to equal the max amount, which is 49,000 seats. Okay. Furthermore, we're told that the price for each section, $25 in section A, $20 in section B, and $15 in section C. And we're also told that from the sold out concert, they make $1,052,000. So therefore, the amount of A tickets times 25 plus the amount of B tickets times 20 plus the amount of C tickets times 15 would give you that $1,052,000. Okay. Finally, we're told the number of seats in section A equals, so section A, the number of seats in section A equals the total number of seats in sections B and C. So the seats in B plus C has to equal A. And so I've identified my variables. I have also gone ahead and created the equations. So now I just need to go about solving, and that's when you need to decide, am I going to do substitution or am I going to do elimination? So I am going to go ahead and do substitution mainly because I've got A equals B plus C. Okay, so let me rewrite our problems here. A plus B plus C equals the 49,000. I have 25A plus 20B plus 15C equals 1,052,000. And then A equals B plus C. Okay, so I am going to substitute. So let me go ahead and choose a different color. So A is B plus C. So for my first problem, I am going to substitute B plus C for A. And so I've got B plus C plus B plus C, and that equals 49,000. And then I'm going to put B plus C in for A for our second one. So 25 times B plus C plus 20B plus 15C equals 1,052,000. Okay, so I'm going to go ahead and distribute, combine terms, that whole shebang. There's nothing to distribute in our first one, so I'm just going to go ahead and combine like terms. So I have 2b plus 2c, and that's going to give me the 49,000. Here I have 25b plus 25c plus 20b plus 15c, and that gives me the 1,052,000. On the next page, I'll show the combined like terms, but basically I need to combine b's and my c's. And so my first equation, again, is that 2b plus 2c equals 49,000. And then when I add the 25 plus the 20, I get 45b plus the 25 plus the 15 gives me 40c, and that equals 1,052,000. Okay. So now at this time, I'm going to have to do some manipulation. So what I'm seeing here is I can easily manipulate the c because if I multiply this whole thing by a negative 20, I can end up getting a negative 40 to be able to eliminate the c. So that's what I'm going to do. So I now have negative 40b minus 40c equals negative 980,000. And then I just tack along that 45b plus 40c equals 1,052,000. So the c's end up canceling, eliminating, they become 0. And then I'm left with 5b equals 72,000. And then I'm going to divide both sides by b, and when I divide by, not by b, oh Lord, I'm going to divide both sides by 5 to find b, and I end up getting 14,400. Okay, so now after I've found b, I found that that's 14,400 seats in section B. I'm going to go ahead and find out what C is. So truly, in order to do that, I'm going to have to come back to one of these equations right here. I can't go back to any originals. I can't even go back to the A equals B plus C. I need to figure out what C is. So what I'm going to do is I'm going to go ahead and take that first one of the 2B plus 2C equals 49,000. And I'm going to go ahead and substitute the 14,400. And when I multiply that, I end up getting 28,800 plus 2c equals the 49,000, And then I end up with 2c equals 20,200. And then I divide by 2. And C is going to equal 10,100. So I've got B, I've got C, and now I just need to find A. And remember, A was B plus C. And so A equals B, which is 14,400, plus C, which is 10,100. And so therefore A equals 24,500. So now when you give your final answer, you would just say, A is 24,500 seats, B was your 14,400 seats, and C was your 10,100 seats. Okay? For the next two examples that I'm going to give in the next video, and just so you know too, for word problems, you're not going to necessarily write them as a coordinate like you did with just normal elimination or substitution problems that we saw in the last video. But in the next video, what I'm going to do is I'm just going to set it up and give you the correct answers. I'm not going to actually work it out because truly I think at this point your setup should be in good shape. It's just more or less about the solving should be in good shape. It's just more or less about understanding the setup, which I think that's what we need to practice on. So that'll be in the next video.